So I think we can move ahead with our next reaction, right? This is the electrolytic combination. All of this we had discussed. Okay. First of all, before I start with the next reaction, everybody, apart from Subhansh, turn on your videos, please. Yeah. Zoha, Meher, keep your video turned on.
Ma'am, my camera is not working today, ma'am.
You all are supposed to message in the group when you are not able to turn on the video. So children, back to types of reaction. Today we are going to do the next two types of reactions. So the first reaction which we are supposed to do today is the displacement reaction. Meher, why is your video turned off?
Ma'am, my camera is not working properly.
Then write the same in the group.
Okay,
Uh-oh.
ma'am.
Where does this go? Okay. So if you look at the term displacement reaction, you can easily observe the main word which is there, displacement. Displace, sorry. What do you mean by displace? Means to remove, right? There is a new child today, Dhairya. Dhairya Singh, are you there? Good evening, Dhairya. You're supposed to keep your video turned on.
Ma'am, may I come in 1 minute, ma'am?
Meanwhile, I'll write the definition. There, you can look at the previous videos which which is uploaded on the app, so as to go ahead with whatever was taught earlier from before today's class. Okay, so children, displacement reaction. It is the reaction in which a reaction in which a more reactive in which a more reactive element displaces a less reactive element from its salt solution. Now, children, one daily life example I'll give you so as to make you all understand about this reaction. And then later we are going to come to the main point of the reaction. Okay. So, children, if at all we consider about your class only, there is a seat which is there. And in that seat, only 2 students can accommodate. And if out of these 2 students, one is a very healthy child and another is very thin child, and there comes another healthy child who is much more healthier than the 2 who are already sitting on the table. And if that healthy child will, what will that do? If at all he wants to sit, he will push you guys and he will be able to occupy the space of any of you, right? Because that child was much more stronger than the 2 children who were already sitting there, right? Yes or no?
Yes, ma'am.
So similarly, the same thing happens in our displacement reaction. There are more reactive, there are less reactive elements. I will tell you how to judge which are more reactive, which are less reactive. So the ones which are more reactive, they tend to take the place of the one which is less reactive in nature, and then they displace it and the reaction occurs. So I will first write the general reaction, because general reaction generally helps you to write the difference. So let us say this is a compound AB and this is the element C. If the element C is more reactive than the element A, then it will take the place of A, and the product which we are going to get is CB plus A. For example, if we take the example of FeSO4 and copper. FeSO4 is green in color and copper is reddish. Copper is reddish brown in color. Reddish brown in color. So, oh, sorry, I have to change it. So first we will take the example of CuSO4 and Fe. Iron is generally gray in color and CuSO4 is generally blue in color. When we put them, then what do we observe? We observe that the reaction occurs and iron takes the place of copper because iron is much more reactive than copper. And we are able to observe the color change from blue to green of the solution. And on the iron nails, we are able to observe the reddish brown color. Clear, everyone? I'll take one more example over here. If we take the example of barium chloride, BaCl2, or let me change it to NaCl. If we take the example of FeCl3, and it reacts with magnesium, then the magnesium is much more reactive than iron. It takes the place of iron and it leads to the formation of magnesium chloride and the iron metal separates out. Now, how do you decide whether this metal is more reactive or that metal is more reactive? We decide by using what? By using a reactivity series. Okay, children? So there is a series of metal in which the metals are arranged in the decreasing order of the reactivity. I'll tell you about the reactivity series now. So reactivity series, what is the reactivity series? It is the series of metals specifically. It is the series of metals arranged in the decreasing order of order of their reactivity. Decreasing order of their reactivity. Fine. So there is a series of metal in which we arrange a few metals which are mostly related to this reaction in such a manner that when we go from up to down, then their reactivity decreases. Fine. Okay. So Dhamshu, keep your video turned on, dear. Dhairya, why is your video turned off? And Sai Siddhartha, are you a new student? Sai, are you there? Okay. So I will write all the elements which are involved in the reactivity series. Acha. Also, this reactivity series, also known as activity series. Wherever, in case you are able to see the word activity series also, it means the same thing. AKA means also known as. Okay, children? Now I'm going to write that series of metal and an acronym to learn that series. Fine. First, we are going to write the series and then we are going to learn the acronym so that it becomes very easy for you people to remember. Okay. So let us start. Sodium. And then I'll write the symbols also. So this is the element. Then we are going to write the symbol. And then we are going to write the acronym. We have to start with potassium. Potassium, sodium,
Ma'am, once can you scroll up?
yes, I will show you the entire thing. Let me just finish writing first. Fine. Okay. I will tell you the acronym also and the symbols also. Oh, I don't know what happens sometimes. So first let me write the symbols and then I will write the acronym. Then I'll give you the time to write all of this. Tin is SN, lead is PB, Henry means hydrogen, copper. Oh, Henry, here we have to write hydrogen, not Henry. Then copper, mercury, silver, gold, and platinum. Children, now let us look at the acronym. It will make it much more easier for you to remember all of this. Fine. So we can learn it in this manner. Please stop calling me a zebra in the library. Henry, call me something good, please. Something good, please. So what's the acronym actually? I'll write it in short over here so that you all can easily remember. Please stop calling me a zebra. Calling me a zebra in the library. Henry, call me something good, please. So now we will see. So if you look at the series which I have written, please means potassium, stop means sodium, calling means calcium, me means magnesium, means aluminium, zebra zinc, in iron, the tin, library lead, Henry hydrogen, call copper, mercury me, something silver, good gold, please platinum. Any doubts? Has everyone written this? Yes or no?
Just a sec.
Yes, ma'am.
Okay.
Ma'am, can you scroll down a bit?
Can I move further?
Yes, ma'am. Yes, ma'am.
Yes, ma'am.
Now, children, an important thing to remember over here is that these elements, first of all of them are metals. Second of all, these are arranged in the decreasing order of their reactivity. So, this is the decreasing order of reactivity. Tell me which will be the most reactive element amongst all of these which I have just written.
Potassium.
It will be potash. What about the least reactive metal amongst the
Platinum.
fine? Children, keep your videos turned on. So many students have their videos turned off. Zoha and Subhansh said that they have problem. What about the others? Keep your videos turned on. Now, children, what's the important thing? It is that After we know which is the more reactive amongst the two comparative metals, then we decide whether the reaction is going to take place or not. Acha, then another very important thing to notice over here is that one metal we take and other is the metal salt. Then we check for, let us say this is metal 1, then we say metal 2. We check for the metal 1. If it is more reactive than metal 2, it will take its place and it will get converted into salt and the metal 2 will get separated out. Now I'm going to write two reactions and I'm going to ask if that particular reaction is possible or not. Or you may say, out of the two reactions which I am writing, which one is possible and which one is not possible. Fine. So FeSO4 plus CuSO4 plus Fe. What do you think about these two reactions?
Ma'am, first one won't occur and the second one would.
What about the others? What do you people think?
Ma'am, second one.
Second one will take place, whereas the first one will not take place. You have to write no reaction. Why you have to write so? Because copper, you have to check if copper is more reactive than iron or not. So if we look at the reactivity series, copper is very less reactive compared to iron. So there will be no reaction because copper will not be able to displace iron. Whereas if we look for iron, iron will be able to displace copper because iron is much more reactive than copper, leading to the formation of the products which are FeSO4 plus Cu. Clear, children? Any doubt?
Yes, ma'am.
I am going to show you the conversion of the color also. So we have done this, we are going to do this reaction tomorrow in our school also. I'll get the picture of this real conversion of iron sulfate. I'll show the initial color of copper sulfate, which is blue. It converts into green. I will show you the video also. And tomorrow I'll get the real pictures also. So on Wednesday, I'll show you. Anyone has done this already in the school by any chance? No, not yet. No problem.
I have.
You have? Good. Those who
Yes, ma'am.
have been knowing about it. So I'll try to see if there is any real video. I think we can see
B
this.
as control sample in test tube. When an iron object is kept in copper sulfate solution, the color of the reaction of iron nails with copper sulfate solution. In this module, you will learn about the reaction changes. Let us perform an activity to find out the details of this color change. For this activity, you will require iron nails, sandpaper, test tubes, copper sulfate solution, thread, clamp stand, and test tube stand. Take two test tubes marked as A and B, and in each test tube pour about 10 milliliter of copper sulfate solution. Fix test tube A on the clamp stand and keep the test tube B as control sample in test tube stand. Now, take 3 iron nails and clean them by rubbing with sandpaper. Tie 2 iron nails with a thread and immerse them carefully in the copper sulfate solution in test tube A for about 20 minutes and keep the third nail aside. After 20 minutes, take out the nails and keep them beside the unused clean nail. Do you observe any change? On comparing both the nails with the unused nail, you will find that the iron nails which are kept in the copper sulfate solution have developed a reddish brown layer on them. Now, take out the test tube A from the clamp stand and keep it beside test tube B for comparison. On comparing both the solutions, you will find that the original deep blue color of the copper sulfate solution has faded away. What is the reason behind these changes? When iron nails are dipped in copper sulfate solution, the iron metal reacts with copper sulfate, which results in the formation of ferrous sulfate and copper metal. In this reaction, iron being more reactive than copper displaces copper from the copper sulfate solution and forms ferrous sulfate, which fades the deep blue color of the solution. The displaced copper then deposits on the iron nails in the form of a reddish-brown coating. Since in this reaction, a more reactive metal iron displaces a less reactive metal copper from its compound, it's a displacement reaction. In this module, you have learned
So color change was clearly observed. This is how only we observe the color change, and I will show you the real pictures on Wednesday also when I'll make my children do that in the school. Okay, children. I'll write one or two more questions related to this, and I would like you people to answer one by one. Riti, you have already answered. You can do in the notebook, but you don't have to tell. Others will tell one by one. I'll write a few reactions, and you have to tell if the reaction will take place or not. Let us start from you, Anuja. First reaction, you tell me, will it take place or not?
Ma'am, it will take place.
What are you going to form? What is going to be formed?
Ma'am, ZnSO4 plus Cu.
The answer will be ZnSO4 plus Cu. Now, children, this is blue in color and this is colorless. You can note down the color changes because sometimes you are asked about these also. Next answer will be given to me by Aryan. Aryan, will this reaction take place or not?
Yes, ma'am.
So what will be the product form?
Ag plus Cu NO3.
CuNO3 whole twice.
Yes,
This
ma'am.
is why I have given this equation also. Beta, you have to write the formulas as per the valency, not
Yes,
by looking at the reactants, because in the reactant, both of them are having valency 1, so the formula is AgNO3. Whereas when the product is formed, copper has valency 2 and nitrate has valency 1. Begin with your chance. Tell me about this reaction, if this is going to occur or not. Abhigya, tell me.
No, ma'am.
No reaction will occur. Abhinav, what do you think will the reaction occur?
Yes, ma'am.
Then
Zinc
what
is more zinc sulfate plus hydrogen less.
very good. Abhigya, this reaction will take place because zinc is more reactive than hydrogen. It is going to take the place of hydrogen.
Okay, ma'am.
Then Anuja has already answered. Dhairya, can you unmute yourself?
Yes, ma'am.
Yes. So Dhairya, you tell me about the next reaction. The next reaction is Mg plus CuSO4. Do you think that this reaction is going to take place?
No, ma'am.
No. Think once again.
No, ma'am.
Meher, what do you think? Will this reaction take place?
Yes,
Meher,
yes, ma'am.
what form?
MgSO4 plus Cu.
Good. There, this reaction will take place. Why this reaction will take place? Because magnesium, we have to check for the metal. Magnesium is much more reactive than copper. So this reaction is going to take place. Children, just a second, I think. Oh, I got disconnected from here also. I will choose one. I'm going to share my screen once again.